Mathematics.
Hello everyone and welcome back. Today we are diving into an interesting math problem that shows how calculus connects to real life. We are talking about the rate of change and we are using boats to do it. Here's the scenario. Two boats leave a dock at the exact same time. One heads east at 40 kilometers per hour and the other travels north at 30 kilometers per hour. Now, the question is, after 2 hours, how fast is the distance between the two boats increasing? Sounds like motion, right? But how do we know it's a rate of change problem? Well, listen for the clue. The question asks, how fast is the distance is increasing? That is classic science. We are being asked for the rate at which a distance is changing over time. And that means we are in the world of calculus. So now, let's break it down.
Problem involves two objects moving in different directions. We have two boats. One travels east, which we'll represent with boat A, and one travels north, which is boat B. The dock is at the origin of our coordinate system. Boat A travels east at 40 kilometers per hour, and boat B travels north at 30 kilometers per hour. After 2 hours, boat A has traveled 80 kilometers east, and boat B has traveled 60 kilometers north. We want to find how fast the distance between them is changing at this moment. Now, let's set up the mathematical relationship between the variables. Let's use x to represent the position of boat A eastward from the dock, y to represent the position of boat B northward from the dock, and z to represent the distance between the two boats. The derivatives are the rates of change. dx/dt is 40 kilometers per hour. The speed of boat A, dy/dt is 30 kilometers per hour. The speed of boat B and dz/dt is what we're looking for, the rate at which the distance between the boats is changing. The key is to find a relationship between these variables. Using the Pythagorean theorem, we can express z as the square root of x squared plus y squared. To find dz/dt, we need to differentiate the distance formula with respect to time. We can either use the chain rule directly or implicitly differentiate both sides. Let's try implicit differentiation. First, we square both sides to get z squared equals x squared plus y squared. Differentiating both sides with respect to t gives us 2z times dz/dt equals 2x times dx/dt plus 2y times dy/dt. Dividing both sides by 2z, we get dz/dt equals x times dx/dt plus y times dy/dt divided by z. This simplified formula is dz/dt equals x times dx/dt plus y times dy/dt divided by the square root of x squared plus y squared. Now we're ready to calculate the value of dz/dt at t equals 2 hours. At t equals 2 hours, x equals 40 kilometers per hour times 2 hours, which is 80 kilometers, y equals 30 kilometers per hour times 2 hours, which is 60 kilometers. Therefore, z equals the square root of 80 squared plus 60 squared, which is the square root of 6,400 plus 3,600, giving us the square root of 10,000 or 100 kilometers. Now let's substitute these values into our formula. dz/dt equals 80 times 40 plus 60 times 30 divided by 100. That's 3,200 plus 1,800 divided by 100, which equals 5,000 divided by 100, giving us 50 kilometers per hour. Let's visualize what this means. At t equals 2 hours, boat A is 80 kilometers east of the dock, and boat B is 60 kilometers north. They form a 3-4-5 right triangle, scaled up by a factor of 20. The distance between them is increasing at 50 kilometers per hour.
And that's it. Now you know the answer and the secret behind solving it. I hope this video helped you understand how rate of change problems work and just how useful calculus can be. That's all from us. Thank you for watching. Bye! Now, welcome to our showcase on how we use AI tools to enhance learning and creativity in the classroom. And let's explore how each student use a different AI platform to tackle math problems, visual projects, and explanations. Let's go! First, Danya used ChatGPT to create a Studio Ghibli-style image, blending art and imagination through artificial intelligence. Meanwhile, Farah explored the world of calculus by asking ChatGPT for an example of a rate of change problem, just like what you might see in an exam. What's a great way to prepare for tests? Next, Alia used Genie to get a word-based solution and also try Goth app to receive step-by-step help with her math questions. These tools made complex problems easier to understand. Then, Amiro simply asked ChatGPT to solve a math problem. With clear explanation, it turned a confusing problem into something easy to follow. After that, Adriana used Deep AI, which gave a detailed step-by-step solution using variables. This is perfect for students who need a clear, logical breakdown of their math work. In addition, Sophia took it a step further by using MathGPT to create a video solution. This tool not only solved the problem, but also helped her visualize every step of the process. And finally, Faiz used ChatGPT to generate a script that explained a math problem in a way that was easier to understand. By turning complex concepts into simple narration, he was able to grasp the topic better and even share it with others more clearly. We hope our journey with these AI tools inspired you to try them too, and make your learning smarter, faster, and more fun. Thank you!